welcome everybody to the FPGA stand-up meeting at Open Research Institute for Tuesday, October 18th. So I'll invite everybody to talk about what they've done over the past week, what they have planned to do over the next week, if there are any resources that are needed, or if there's any roadblocks in the way. And I'll start out with just a brief encoder update of everything that I know, and then turn it over to James and Sasha and Everest and anybody else that is able to attend. So these are a little bit of encoder updates. This is the encoder. This is the downlink. And so we have a couple of problems that we found recently. One of them is there's a problem in the inline config adapter. Case switch for the config, which is the enumerated tuple of the frame type constellation encode rate, has some combinations that aren't in the tables in the spec. So I volunteered to write a pull request for that. And then I think we should really start looking hard at adding DVBS2X after we get DVBS2 working. And DVBS2 is not yet working completely. We're not getting the expected behavior with DMA to the encoder to the DAC FIFO path using IIO, or industrial input and output, really powerful library. This is using these calls is a different approach from writing low-level DMA code or using the old Mykonos structures and systems. So what's happening to us with the encoder is that the configuration word is getting corrupted somehow along the way, and that means that it changes behavior. It doesn't understand what code rate or modulation or frame type it has anymore, and it's causing a transmit buffer timeout in IIO. And about that buffer, so we were using IIO buffer push, which shoves out the entire buffer that you set up. And Everest recommended to look at the IIO buffer push partial. This is a much more flexible call. So partial is probably the right answer, because then BB frame lengths can vary. So what we tried to do is set up single words to push out a single word, either all zeros or all ones or whatever. This usually worked. This the encoder puts out a signal. There's some problems with that signal in the ZC706, which I'll mention very shortly. But the sending single words to the buffers, filling up the buffer and shoving it all out usually worked, but sending files like BB frame files isn't yet working, and so help is still needed here. We have some additional capabilities. The MQTT approach from Everest and Anshul is working on the Pluto, but not yet working on the ZC706. This will be a really powerful way to do things when it's working for everything. We do have a Python notebook that takes a TS or a TS file or transport stream file. Generally, you can assume that this is MPEG. Eventually, we're going to do GSE, the generic stream and encapsulation, but right now we're working with TS files because the receivers are more plentiful, easier to test. But it takes a TS file, turns it into BB frames. It's a Python notebook, and this matches the block in GNU Radio that produces BB frames from a TS file. You can use either one, but if you don't want to install GNU Radio and you're okay with using a Python notebook, then you can get a BB frame file of BB frames from a TS file. And we've improved, just consistently improved over time, the processor side operations. We now have everything from bit file to PS workflow documented. We can operate the station with IO calls on the processing side. And we've done this multiple times, and we're getting a lot better with essentially setting up the station from scratch to getting applications working on the processor side. There's some updates on resources and reaching out. Welcome to Sasha and Janani. These are two new people to the FPGA team. Please look for them and make them feel welcome. We've gotten some additional community support. The Ham Expo presentations about our work went very well again. In the past, Andre and others have, Anshul especially, have presented at Ham Expo. We did it again and got additional good feedback. And we've had a pretty high level, wide-ranging set of presentations to JAMSAT. So thank you everyone for helping getting out the word. It doesn't happen without people actually pushing and saying things and going out there and introducing it. So please help spread the good news. And then in terms of articles or papers, we wrote an article about the forward error correction on the uplink for opulent voice. This is very likely to be published soon in a national publication. We should really follow that up with one about the multiplexing and the encoder work that we're doing here. So here's what currently what the encoder looks like. This is what the wrapper looks like. This is what gets placed in the HTL. And the two main chunks of it, well, you have input data and output data, of course. And in our case, we're taking in data from BB frames. So it's at the baseband frame level. Data width is 32 bits. It's expecting 32 bits in. And so that's the data mismatch, the bus mismatch that we just fixed yet again. So it's the default from the reference design is 128, and we forgot to change that. We thought maybe some of the more recent problems were because of that, but that cleaning that up didn't fix it, or didn't fix it completely. Once you get into the wrapper, you have an inline config adapter. This handles when we have a BB frame, it's not just BB frames, it's one word that is the configuration word with the frame type, constellation, and code rate. And the job of the inline config adapter is to figure out which one of those 32-bit words is that particular special word, and then break it down into enumerated types and feed the encoder. You can see that the encoder has these things that go into it. And so those two entities in there, that's what's in the wrapper. And then what comes out is IQ data. So it's 16 bits IQ, 16 bits I, 16 bits Q. This is the format that the DAC FIFO is expecting. However, we're outputting 32 bits at a time, not 128 bits wide. That's the next thing I think we should probably fix, and we'll probably start seeing better spectrum results on the ZC706. If you drill down, just look at the encoder. This is what it looks like. So lots of AXI, but other than that, pretty straightforward. The data comes in, and the encoder frame type, constellation, code rate from that one word comes in as well, and then IQ out. And this is backing up a little bit. This is how it fits. So before the TX-DMA controller went directly to the DAC FIFO, we've gotten in the middle of that with our encoder, and now we're just trying to make it work. All right, so I'm going to turn off sharing, and then, hey everybody. So that's kind of a summary of where we're at from what I know, and so I'd like to turn it over to, let's go with Everest, and let us know what you think and what additional things we should be working on.
Okay, I don't know if you can hear me.
Yes, you sound great.
So, yeah, so good step forward as you work a lot on the fixing all this issue. So I write a minimal example which should work on both platforms. So on Pluto, which is working right now, and just by define, it should be work on the ZC706. I think, well, maybe there is some HDL difference between the both. So maybe we have to investigate the difference between the both. I can also make some more trace or debug, which means that we can, if we can have the register of the encoder on the Pluto and on the other platform, and we can maybe inspect what's the issue. So I think that I had a dump of the register after each write to the encoder. Yeah, so that's it. I just have a quick question. I try to understand how to change the sample rate on the AD, well, 9371 with this 706, and it's because with IO it seems that we can't change the sample rate right now. So maybe I missed something, but
no, we tried to
I
look for
don't
that.
see how to change it.
Yeah, we tried to look for that too yesterday. I don't know how yet. It did not seem to be obvious. So you're not alone. So
Okay, because
let's try to figure that out.
yeah, because it seems that the initial sample rate is about more than 100 megahertz.
Yeah,
So we know that,
122.
yeah, and yeah, and so we can't have DVB receiver which handle that. So we have to figure out how to change the sample rate. My idea is maybe that you can't change the sample rate itself, but add some stages after that to decimate. And this is what happened on the Pluto itself, but the IO handled that. So I wonder how it is done on this platform.
Right. Yeah, I'm with you and understand. We may have to, at least the old way of doing it seemed to be to set it up using the transceiver evaluation software, that TES software, and then that you set it all in there, and then you get this C file or Python, either way, and it's an export from TES, and then you put that that was part of your code for the old way of doing it, but now we want to use IIO. So there has to be something in IIO to set all of these values. So I'll do all I can to figure out what the right way is. And of course, if anybody watching this knows, please help us out, and we'll be able to make some quicker progress.
Yeah, because normally IO is simplify the multi-platform, which means that if I do that on Pluto with sample rate, I could have the same behavior on another platform, just with little change. And right now it doesn't work anymore. And so I don't know if it is the IO driver of the 1971, which is not finished, because the documentation is not as detailed as the 1961 or 62.3 of the Pluto.
Yeah.
So
okay,
maybe we have to ask question to ADI on that.
Okay, yeah, that sounds like something to ask them. And yeah, good observation.
Just the last word. It's now very easy to test for me, and going to the ZC706 directly on SSH, and I think that you have seen it. Well, the binary which is on the MSD.
Yes.
And so it's very, very convenient. Thanks for this remote lab.
Oh, you're very welcome. Yeah, just let us know if there's anything that you need at all, and we'll try to do it.
Okay, great.
Awesome. All right. So, Sasha, please welcome. Go ahead and introduce yourself if you'd like, and let us know what you'd like to accomplish. I believe this is the first time that you've made one of the meetings, so please, you have the floor.
Does my audio work?
Yes, you sound great.
So, yeah, I would like to work on getting the DVB-S2 transmitter working. And I guess I'm just as a bit of background, a friend startup does want a DVB-S2 transmitter for satellite use, and they're okay with paying me to help make it happen. And obviously this project seems to be quite advanced. I don't really think I could do that much work in the time span that they want me to get get a transmitter done and working and tested. So I guess I really I don't have anything specific in mind for what I want to work on, just anything that gets us closer to a working transmitter. And that would include like the hardware, the software, the gateware, testing it, all that good stuff.
Wonderful. Yeah, welcome aboard.
Welcome aboard. Thanks. And I guess the question I do have, so obviously everything so far that I've seen in the meeting today has been about the gateware and software. I'm wondering, what's the state of like the hardware, like hardware development?
Yeah, that's a good question. So right now, what we're on is it's called a ZC 706 or 706 is what we call it, but it's a 706. This is Xilinx FPGA development station. If you're in FPGAs, you're probably familiar with it. So that's the platform, the hardware that we're working with today. Attached to it is something called an ADRV 9371, and that's the 9371 RF SoC from Analog Devices, and that's their development board. And so these two boards fit together, and they make a radio FPGA radio development platform. So that's where we start and get the hardware working. So it's a Xilinx target. We also have a trends module, which is this drops a lot of the peripherals off so that you're dealing just with the FPGA. So we have that waiting for us to use to take the next step in order to make our own board set. So the board set will include everything that you need in a payload, and that includes so the encoder is a big part of that for the downlink, obviously. And the uplink receiver is the work for that protocol is pretty far along. There still needs to be some work done there for the uplink, so that and the hardware for that same development station, but we do not have any HDL working yet. That's just begun. So that's sort of this hardware status and the hardware path that we have. So our goal is to end with actual custom boards for space.
Yeah, I guess I'm specifically so I understand the setup with like an FPGA dev board and then a board with the 80 chip that takes in IQ samples and outputs like RF.
Yes.
And I'm wondering, like my company would like to have something that outputs X band, and I don't think that 80 part outputs in the X band. I think it tops out at like 5 or 6 gigahertz.
That's correct. What we're doing with the dev board, what we have today is making sure that the baseband works, essentially the baseband. So we're testing at, I think, what are we testing at? Right now we're testing at 2.5 gigahertz. And there is additional RF hardware that's going to be needed to get to 10 gigahertz, which is our particular goal for the downlink. So the satellite subband for amateur radio is what we have targeted. We have 10 megahertz there, and that's the goal for the hardware. The uplink's on 5 gigahertz, similar band, similar subband. And then the path that, we're also looking at 24 and 47 gigahertz hardware for this. But no, by itself, the 9371 will not do 10 gigahertz on its own or anything higher. So that's true. There's additional RF hardware needed. There's some designs that have been sketched out, and some parts were picked. And then COVID has really kind of changed the schedule for a lot of this, including FPGAs. As you know, it's kind of tough to get them. We're very lucky that we have the boards that we have, and we can make progress on all this stuff. But the building of the 10, essentially an up converter for 10 gigahertz, kind of stalled out. So there's plenty of interest and a very slow amount of progress, but because a lot of people were kind of scared away from doing part selection. What we do have is a lot of surplus parts and parts from that have been donated or but these are ones no longer available for a while, right? So lots of silver boxes and filters and amps and things. So that's where we're at on the RF side.
Okay. I guess I'm wondering where would it be useful for like me to contribute, helping stuff out with the gateway or software side, or would like an additional pair of hands on the like RF side be appreciated?
That's a good question. Let me think about it and get back to you very quickly. Because the problems that we're having with the HDL on the encoder well, we think these are probably problems with the software. So if your interests were to also use IIO, if you were interested in using that library, then it would be of benefit to pitch in there, because you would be contributing directly towards something that you'd be interested in seeing open sourced quickly. But there is a lot to do. There's a pretty big backlog on the RF side. So let me think about it, and we'll talk more and figure out what might be the priority.
Thank you so much. I'm really happy that this group exists, and I'm really happy to be able to contribute.
Thank you.
Getting it so everyone can have a DVB-S2 transmitter for their satellite. I'm really happy.
Yeah, that's the goal. Right on. All right, James, tell us. Oh, sorry, Sasha, I didn't mean to cut you off. Is there anything else that you wanted to talk about?
Nope, not really not really for the stand-up. I mean, I'm on Slack and we can chat later. So
Okay.
Thank you so much.
You bet. All right, James, how's it going?
It's going fairly well down here in Remote Lab South. We've finished moving one of the really big pieces of equipment out of the building that we'll be using for that'll be the permanent features for Remote Lab South. So we've got a lot more space to move more equipment in and start getting a lot more stuff set up down here. So it's going to be nice. It's one of our like biggest and heaviest pieces of equipment we had to move around, and so it was nice to finally get that done.
Yeah, I saw the photographs. Well done. That was a lot of work.
Thank you. But yeah, that's pretty much all to report from Remote Lab South. We're continuing work there. Environmental controls are pretty much set up in the new building, and we're just going to get more and more equipment set up.
Fantastic. Yeah, let me know if you need anything at all.
We shall.
All right, Paul, you have the floor.
You cut out briefly, but I think you said my name. Nothing to report about Remote Lab West. It's still there, and I've been using it to develop these FPGA tests. I've been helping out, working on that with Michelle. And that's pretty much what I've been up to. I don't have any new roadblocks or anything going on for the meeting.
Good. All right, and we have some interest in getting polar codes up and running, and I'm hoping that we can use, at least for Remote Lab, at Remote Lab West, we do have the ZC706, which is not something that we have at Remote Lab South. Remote Lab South has an UltraScale Plus, a ZCU106, and we have the same board here in Remote Lab West, and it's been somewhat underutilized. I'd like to start getting more projects on that. So I'm trying to build up a small team of people that are interested in polar codes. So these are pretty tricky. They are arguably better than LDPC, which is essentially gets you up to capacity. So if you're listening to this and you want to see more open source work for polar codes, which are used in 5G, lots of research activity around polar codes. They're great. They're complicated. So I can promise you a pretty steep learning curve, but plenty of support and a powerful development station to use for FPGA design. And very shortly, we'll be kicking off our artificial intelligence and machine learning handbook effort for getting practical sort of AI ML open source work done. This may not be exclusively FPGA, but if we see anything that might be of use or could be deployed using FPGA stations, then the remote labs will be the place where it will be offered as a resource for that. All right, any last comments or questions before we close for the day? All right, thank you, everybody. We'll keep whacking away at the encoder problems, and I'm highly confident that it's going to be producing some just as good spectrum as the Pluto did. Thank you so much to everybody for helping, and we'll do this again next week and see you on Slack.